Hello, beautiful people. Let's welcome to 4446 kind of combo here. Really, our main idea is a composition, a creation. It's actually also a combo. So, combo of transformations. So whenever you see composition of transformations, we are doing a combo of transformations, a combo of two or more performed together. The notation, all right, so it says XY, so that's the thing that you're going to do it to. So like whatever the shape is or the point is or whatever. You actually do the one closest to it first, and then you'll do this second one second. So a rigid motion, just a reminder, maintains the size and the shape of the figure. So the image and the pre-image are congruent. And then your similarity transformation. So whenever you have a dilation, if you change the size, it's the same shape, but it's a different size, the image and the pre-image are similar. So this is just some vocab words. So let's see, a rigid motion is an isometric. It's isometric because it creates congruent sides. So these are all going to be congruent shapes, isometric. And then whenever you have a dilation in there, it becomes a non-isometric because it does not preserve the size. They create similar shapes. Just a little bit more vocab. So similarity is non-isometric. And a rigid motion is isometric.
Everyone, please go to your
Sorry for the announcement. All right, so graph the image of each composition. So we have the OG. We gave you all those points. And then the thing we do first is the thing that is closest to it. So I need to go right, left, 0, down, 5. So you can really just subtract 5 from each one of these points. So this was -5, 2, so minus, so it's going to be -5, minus 5 is -3. -5, -3, T prime is going to be right there. E prime is going to be down 5, 1, 2, 3, 4, 5. So that is -1, -2. And X prime, 1, 2, 3, 4, 5. is going to be -2, -4. We are not done though. So this is the shape with one transformation. Now we have to do the other transformation. So after we've done this, we take it, we're going to reflect it over x equals 1. So x equals 1 is right here. It crosses the x. So let's see, the E is 2 away, 1, 2, so go 2 more. We call this E double prime. So that E is at 2, -2, excuse me. The X is 1, 2, 3 away. So we go 1, 2, 3 more. X double prime is at 4, -4. And then T double prime is 1, 2, 3, 4, 5, 6 away. So I'm going to go 1, 2, 3, 4, 5, 6 more on the other side. Gives me T double prime at 7, -3. And so now I have a shape that was translated down and then reflected over. This is going to be a congruent shape. It has the same size, same shape. It is isometric. Because we didn't do a dilation. All right, let's try another one. So I have JKL here. So we do the one closest to it first. So that's a translate. Left 1 down 3. So let's see, J is going to end up at 0, 0. Left 1 down 3. There's J prime. K, left 1 down 3. Left 1 down 1, 2, 3. And L, left 1 down 3. L, left 1 down 1, 2, 3. All right, but we are not finished. We need to now rotate this figure 90 degrees. So our 90-degree rules are switch x and y, change the sign of the new x. So it's negative y comma x. So we're just going to keep j at 0, 0. J double prime is still 0, 0. K double prime, switch x and y, change the sign of the new x. So it's going to be 2, 0. K is at 2, 0 right here. K double prime. And L double prime, switch x and y, change the sign of the new x. So it's at 1, 2. We're getting a little crowded up in here. But there's my double prime. So I shifted left and down, and then I rotated, whoop, 90. That is a congruent figure. Okay, let's do another one. Reflect across the y. So this is my y-axis. I have E double prime. No, just E prime, Mayhew. I've been doing that in blue. Let me do the first one in blue. E prime is at 1, 3. T prime, so it's negative 5 away, so I gotta go up here. T prime is at 5, 2. And X prime is at 2, 1. Good, good, good. So T double prime, what are we doing to it? Dilating it 2. So if I want to dilate this shape by 2, I need to multiply all these by 2. And this is why it's a bigger graph, so that you had the space. So 10, 4. T is at 10, 4. T double prime. E double prime is at 2, 6. E 2, 6. E double prime. And X is at 4, 2. 4, 2. X double prime. So now it's the same shape, but we've gotten a good bit bigger. So it is just a similar shape. It is non-isometric because it's a similar shape. Like they have the same angles. It is the same shape, but it has been multiplied to get bigger. Alrighty. One more of these examples. Let's see, this one, rotates, then translates. So rotate by 90. So this is going to be a rotate by 90. And then a translate after I do that. So let's rotate by 90 first. So if I'm going to rotate this guy 90, that is switch x and y, change the sign of the new x. So negative 3, 1. Negative 1, 1. Negative 2, 3. Let's draw it. Make sure we got that right. Negative 3, 1 is J prime. K, negative 1, 1. Makes sense. And negative 2, 3. Negative 2, 3. Doot, doot, doot. Yep, that is a rotation. We're good to go. And then T, down 3, left 1. So if this is very, very similar to the one right above it, it's just showing you that order matters when you do this. So yeah, we're going to end up in a different place, which is interesting. So left 2, down 3. No, left 1, down 1, 2, 3. So negative 4, negative 2. That is J double prime. K, left 1, down 1, 2, 3. K double prime, negative 2, negative 2. And L should be negative 3, 0. Left 1, down. Oh, see? Look, I went back to the black one on accident. You got to go left 1, down 1, 2, 3. There we go. Negative 3, 0. There's L double prime. Got to be careful. So it's interesting because even though it's the same set of transformations, so like this one, we did transform, then rotate. This one, we rotated, then translated. You end up with different shapes in different places. And this is still a congruent figure. It is isometric. We're good. What series of transformations would map triangle ABC to DEF? So how could I get from here to here? And it's a series, so we're gonna have to do 2 different things. Now this is a little bit more complicated because you're kind of guessing and checking. Could it be a rotation? I think it's going to be a reflection and then a slide. So if I reflected across, I've been doing blue first. If I reflect across the X, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Is that going to be in line? Yes, it is. There we go. So it looks like it's a reflection over the X. And then a translate, we didn't go up or down any, so a translate 3, 0. Oh, further than that, Mayhew. So my translate is going to be, to get from here to here, would be 1, 2, 3, 4, 5, 6. If we give you these, y'all, it will be multiple choice. It will be a way that's obvious to see. We just want to see if you can figure it out. If you can figure out it's a reflection, then a translation. These are hard. We don't expect you to be able to do it perfectly. All right, so to get from here to here, ooh, that looks like it is also a reflection, then a translation. So we have over, so 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. Does that reflect? It does, and then it scoots down. So we have a reflect over the y-axis, and then a translation down. Let's see how far down. 1, 2. So 0, negative 2. Oop, keep forgetting to do my vector format. Great. Give those a shot. See how you do. And here is your homework. Some more compositions. Hope it helps.